Let's take a look at solving basic logarithmic equations. First, a quick memory check. When you were switching from logarithmic form to exponential form, you would say a raised up on its shoulder, a raises the y up on its shoulders, and it equals what's inside. And so you get this exponential form. And what we're going to do is switch back and forth to whichever one is handier to be able to find our variable. Now, you have a couple different places that your variable could be. Your variable or unknown could be sitting over here. If that's the case, that means you have numbers here and here. You can use your calculator very quickly to find your variable value. If the variable is sitting here in the A, we're going to switch forms. So we're going to say A raising the y up on his shoulders equals what's inside. If the variable is sitting in here, we're going to do that same thing and switch over to exponential. For exponential, if the variable is sitting here and both of these values are numbers, that's not a problem. You just take whatever this number is and raise it to that power. Now, if the variable is sitting here, which means that the x is a number and the y is a number, then you can just take the root of both sides to whatever root power this is and be able to get to that variable that's sitting here. The last one that you have is when that variable is sitting here and you have a number for the a and a number for the x. Now you're going to need to switch to logarithmic form, because when you do, that y is sitting out here and you have just numbers in here. Let's take a look at what those look like. So here, we need to solve this logarithmic equation, so that means we're looking for the x. So we're going to convert forms. We're going to take the 5, lift the 3 up on its shoulders, and set it equal to x. So we're going to say 5 raised to the 3rd power is equal to x. Well, that's not a problem, because 5 cubed is 125. Remember, several videos ago, you went ahead and memorized some of those basic powers. And you can write this solution like this, or you can put it in set form. When you do that, we like to check our solutions. When we check them in logarithmic equations, you're sticking the 125 in here, which is really saying 5 raised to the 3rd is 125. Yes, that's true. So our solution is 125. Now, here we have a variable inside again. Let's go ahead and convert to exponential form. 3 raised to the 2nd power equals what's inside. So 3 raised to the 2nd power equals what's inside the logarithm, 3x minus 2. 3 squared is 9. We want to get the x term by itself, so let's add 2 to both sides. 11 equals 3x. Now we want to undo that multiplication of 3, so divide both sides by 3, and you get x equals 11 over 3. Let's go ahead and check that. When we do that, we put 11 thirds here. 3 times 11 thirds is just 11. 11 minus 2 is 9. 3 squared equals 9. So the check works. Now, this one's a logarithm, but it's not a problem for us because we know this is base e, and we can say e raised to the 8th power equals what's inside. So e raised to the 8th power, that comes from here, and this, remember, is this base e, and it's going to equal what's inside. For those of you who remember logarithms, there's going to be a shortcut next week when we're working in new sections and learning properties. But at this point, what we have are like bases, so that means we can equate those exponents. 8 equals negative 2x. Divide both sides by negative 2, and when you do that, you get 8 divided by negative 2 is negative 4. Let's go ahead and do a quick check of that x equals negative 4. Here, we're going to put a negative 4. Negative 4 times negative 2 is 8, so e to the 8. Check the conversion, e to the 8 equals e to the 8, and we like that, so our check is complete. Now we have something a little different. The variable is sitting down here in the exponent. If these were numbers in this base and base, we'd have to convert. So here, this variable sitting here, we're going to have to do a conversion to exponential again. So x cubed, that's from this, is set equal to what's inside the logarithm, which is 1 over 8. Now we need to work towards getting some kind of solution here. And what do you think? We got a fraction, and we have this power here. I hope you're thinking you want to take the cube root of both sides. So let's go ahead and do that. You got a fraction over here, though. Do you want to go ahead and convert this to an exponent? That might be easier when you go to take a root. 8 is 2 cubed, and we want to move it in the fraction, so that becomes 2 to the negative 3. Let's take the cubed root of both sides now. And when you do that on the left, you just get an x, and on the right, you're going to end up getting what? 2 to the negative 1? I'm hoping that's what you're thinking. And so why is that true? Let's go ahead and finish this, and then I'll go back. This is 2 to the negative 1, which gives you 1/2. So why is the cubed root of 2 to the negative third equal to 2 to the negative 1? We can rewrite what's inside to be 2 to the negative 1. Sorry, that's an exponent, raised to the third power. When you do that, this 3 matches the index of the root, and when that's the case, then the base that had that exponent gets to come out. If you're having trouble with that, you should come see me, and I can do more examples and help you figure that out. You should do that before you come to class next time. So now let's check this 1/2, and what does that look like? So there's a 1/2 here. Raised to the third power, is that equal to 1/8? Well, 1/2 raised to the third power is 1 to the third power is 1. 2 to the third power is 8. So this is 1 over 8. And that's exactly what you wanted. So this check works as well. Here's another one. Log base 5 of 625. Now, next time, we're going to be able to figure out what's happening. That means next week. So for now, let's go ahead and convert this to exponential form. 5 raised to the x equals 625. The only tool we have in our tool bag right now is to equate exponents. And 625 is what raised to the power. The hint, right, is this. And so 5 raised to what power? Should be the fourth. I hope you're getting ahead of me here. X to the fourth then is equating exponents. So let's go ahead and check that. When we do, we want a 4 here. Substitute that in. 5 to the fourth. What's 5 to the fourth? That is 625, and so that works. Now we don't have a logarithm. We have exponential form. So let's go ahead and convert this, because here we have this variable is sitting here in this exponent, and we cannot make 13 e to the something, so we could equate exponents. So we don't have that tool. Instead, let's go ahead and convert to logarithmic form. It's a base e, so we know we're going to have the natural log. And how do you decide what goes where? This is e raised to what's on the other side, so the negative 2x plus 1 goes over here, and it's equal to what's inside the logarithm, so 13 goes there. And over here, negative 2x plus 1. So you're thinking, do I have to actually have some value for this? And the answer is no. Remember, on MyLabs Plus, you're going to put exact answers unless they ask you to approximate. So that means then we've got to get this x term by itself. We're going to subtract 1, then divide by negative 2. So subtract 1. So you get the natural log of 13 minus 1. We used a parentheses here to separate that negative 1 from floating inside this logarithm. And then we get the negative 2x along for the ride. Let's divide by negative 2. And when you do that, you get the natural log of 13 minus 1 all over negative 2. And that equals x. Now, you have some options here for what your solution can look like. This negative in the denominator is a little odd, and so we can rewrite this by factoring a negative out of the numerator and denominator to get 1 minus the natural log of 13 over 2. We can check that. This one's a little bit more complicated. If you try to substitute this into here, it's not going to look very good. It's possible, but I'm going to leave that to you and in your own time. And this does check out, so you should spend time to do. Here's another one. If you can, go ahead and convert that to logarithmic form. I think the issue some of you may have is this 4 sitting here. Let's go ahead and divide both sides by 4. And that gives us e to the x plus 1, and that equals 5 over 4. We do this so that we can get the e by itself. This is going to allow us to convert to logarithmic form, and it's going to be the natural logarithm. So we're going to have the natural log of something equals something. This is base e. It's going to raise the e up to what goes on the other side, so that's x plus 1. And it's equal to what goes inside, and that's 5 over 4. So now that you have that, we need to get the x by itself, so let's just subtract 1 from both sides, and you get the natural log of 5 over 4. Again, use the parentheses to keep that negative 1 from floating in, and you get the natural log of 5 over 4 minus 1. Again, the check is not as pretty, but this will work out. I leave that to your own devices. So at this point, that's it. What I'd like you to do is please copy examples 8 and 9 from your book, and that's on page 444. Remember, keep your notes looking very happy and organized using a highlighter if you can, so that when you go back, you can actually find things that you've written in your notebook. Hope you're having a terrific night.